Hey, District 211 Automotive Technology students. I'm Mr. Tulo from Conant High School, and today I'm going to talk to you guys about engine bottom end fundamentals. So, just to be clear, when we're talking about an engine bottom end, we're not talking about complete engines like this. We're talking about when you get the cylinder head, exhaust and intake, and everything, all the accessories and stuff on the front end of the motor removed. Okay, so if you haven't gone over that yet with your instructor, you should be doing that first. What we're talking about is bottom ends or short blocks. Okay, so first I want to talk to you guys about the engine blocks themselves. I have 3 examples here. And then we'll go into the rotating assembly, the crankshaft, connecting rods, and pistons. So we have a bare inline 4-cylinder here. This is one of our Mitsubishis, the 4G64, I believe it is. And what we're looking at here is a cast iron block, and it's really dirty, so you can't really tell. I mean, I can tell, but maybe you can too, because it's so much darker. But without really checking it with a magnet, you may not know. But that's the easiest way to know if you're dealing with iron or aluminum. As you get more experienced, you'll realize the aluminum is a lot shinier and you can kind of just recognize it, but a magnet's always a surefire way to tell. So this block is cast iron, and you can see it's just a really, really basic design. We have 4 head bolts per cylinder. Okay, so not a lot of clamping force on the cylinder head. All of these holes are coolant passages where coolant will pass from the engine block into the cylinder head. And you can see on the front end, this is obviously where the water pump was, so this is where the water starts flowing into that engine block, and then it gets pumped out the top. Other things you can see here, this is a hole where a balance shaft went, so this engine has some sort of balance shaft set up to make it, seemingly run smoother. And I can see the block goes below the center line of the main cap. So this is technically a skirted block. If you think about a skirt like the clothing, it does the same thing. It hangs down around just like this engine block does. It hangs down around the crankshaft and rotating assembly. So I would expect this oil pan to be pretty shallow. So there's that. This is a small block Chevy V8, and I can see here again, this is an iron block, but this is not for a balance shaft, that's for the camshaft. So this is actually a cam in block engine. You can see the holes where the lifters are and stuff like that. So this is a really old school engine block. It's been this way since the 50s. And you can see we have more clamping force for the cylinder head with this. You can see there's actually 1, 2, 3, 4, 5 bolt holes per cylinder instead of 4. So we'll get a lot more even clamping force of the cylinder head around these cylinders, which is good for power potential. On this block, we can see the center line of the mains is where the block is cut off. So this is not technically a skirted block. Okay, so other things we can see here, same thing. Here's the water jackets. You can see the water jackets down in here, and here's the passageways where coolant flows. The water pump pumps it into these 2 holes to each bank. The coolant flows around the cylinders and then goes up to the cylinder head. And on this engine, it's got a wet intake, so it flows into the intake and out. Another thing you can notice here is the oiling system. This oil pumps in the rear of the engine block, right on the last main cap, and it pumps oil into our oil filter housing here through this passageway. And what that feeds is these 3 main veins that go down the entire length of the engine block. If you look on the rear side, you can see it's drilled straight through. So that is how our oil gets to the mains, the camshaft, everything like that is through these 3 main veins here called galleys. So you'll notice on the deck, there is no oil passageway on the deck, so there's no pressurized oil going up through the cylinder head. How it gets to the valve train, the rockers and the springs and everything like that, the valves, is through the push rods. As the lifters get oil, they fill up with oil. and pass oil through the push rod up to the rockers. So that's how these small block Chevys get oil. Lastly here, I have a little GM 4-cylinder, and this block is aluminum. So I could tell right off the bat by its color that it's aluminum, and another telltale sign is A, it's not going to be magnetic, and B, aluminum blocks are not strong enough just to bore out the aluminum and hone it and throw a piston in there, because the piston's aluminum too. So what they do is they put cylinder inserts or sleeves in, and you can see where they meet right here. These are actually pressed fit. They're usually ductile iron, and they press fit into the block. They are replaceable, but it's a huge job. You pretty much need a machine shop to do it because it needs to be machined after that anyways. But it's like a really strong part inserted into a relatively weak block, because cast aluminum is definitely not as strong as iron, but the weight savings are very, very worth it, especially for a lower output engine like this. Another thing that makes this block a little bit weaker is these cylinder inserts are kind of floating in the block. You can see coolant can flow all the way around. So the only thing tying them together is actually touching each other. And this is another block that only has 4 bolts per cylinder head. Okay. I can see this is an overhead cam engine because of this right here. This is where the timing chain would pass up to the actual cylinder head. I know it's a timing chain because I could see there's a few sprockets still on that block. And this is another non-skirted block. And this brings us into our talk about main caps. So this is technically a cradle assembly. The bottom half of the block is actually integrated with the mains. This is a really good design when you're using a weaker material like aluminum, because it ties all of this together. The crankshaft is bolted in with the structure of the engine. This is a very, very strong design. It's a good design, and it's necessary when we're talking about aluminum. These main caps, this is a 2-bolt main block. There's also a version of this block where these main caps are wider, and there's another bolt over here and another bolt over here. So that would be a 4-bolt main, but these main caps are individual. They get unbolted individually. So that's a huge weak point for this small block Chevy. That's why they made those 4-bolt blocks, to tie the bottom end together a little bit, give the crankshaft a little bit more support. There's also ways like, let's look at this thing real quick. This is a main girdle. So it's not technically a cradle because it's not the bottom half of the engine block like that aluminum block, but it's a girdle because it's all one piece. They're tied together. Still only 2 bolts holding them in, each one, but the fact that it's all connected together gives it a little bit more rigidity and stability. It's all about stabilizing that crankshaft motion, because that's what deals with the hardest life, basically. What's cool about this skirted block, like Mopars and LSs and stuff like that, with a skirted block, sometimes they could do side bolt or cross bolt mains too. So you could have 4 bolts holding the cap in vertically, and then another set of bolts going in from each side to help tie that in together too. Like LS engines have cross bolts like that. So that's technically a 6-bolt main. So when you hear people talking about that, you know, buying and selling engines, they're like, oh, this, you know, I want more money for this because it's a 4-bolt main block. That's what they're talking about. Now let's talk about crankshafts real quick. We have 2 crankshafts from 2 very different engines. We have the cam and block V8 here, and then we have this overhead cam inline 4-cylinder. So first, similarities that I notice. They both have a rear main seal surface. They both have 5 main journals. These are main journals because they're both supporting 4 cylinders. So in between each of the 4 cylinders, they support the crankshaft with a main. So it spins true and has a lot of support, doesn't deflect, all of that good stuff. This crankshaft is the same way. I have a big rear main seal surface down here. and then 1, 2, 3, 4, 5 mains. A little bit bigger, but the amount of main journals is exactly the same. They both have counterweights opposite the rod journal. So this is the main journal, this is the rod journal. The counterweights are to offset the weight of the piston and connecting rod assembly. If you look closely at it, you can see there's holes drilled in it. There's weight taken out. This one's pretty deep. They took a lot of weight out of the crankshaft right there. What happens is you put it on a machine and you clamp weights that are equal to the piston, connecting rod, piston pin, piston ring assembly onto here, and a machine spins it up and tells you you either have to remove weight here or add weight here with a heavier metal like Mallory or something like that, tungsten. So those are where the similarities end. If you look at this connecting rod journal, there's only 4 connecting rod journals, and it's an 8-cylinder engine. Well, how do they do that? It's because each journal is twice as wide. So 2 connecting rods have to sit next to each other. This is why these V8 rods, the direction is so important, because you can kind of see a little radius or curve built into the crank here. And if you look at our connecting rod, one side of it has a chamfer or an edge cut, and the other side is almost flat. So the 2 flat sides, the connecting rods actually have to slide on each other. Okay, then the outside where the chamfer is where it clears the radius of the crankshaft. On these pistons and connecting rods, both sides look the same. Okay, and there's always a little bit of piston pin offset where the connecting rod doesn't sit exactly in the middle of the piston, because it helps with engine noise, piston slap, and just basically makes it centered in the cylinder better. They figured that out years ago. So those rods need to be installed in the correct direction too. The easiest way is to look for a forward mark, like this dimple. Okay, so other than those rods being different, I do see more similarities here. They both have studs, and I could see someone hit the stud out a little bit, but they both have studs and nuts to clamp the caps on, and both the bearings have bearing tanks. Okay, so they have the same method of preventing the bearing from spinning. They also both have 3 piston rings. We have our 2 top compression rings. The second ring kind of has, it wears 2 hats. It helps wipe oil and it seals in compression, so it's probably a little bit different cut shape than the top ring. And then the third ring is the oil ring. Okay, so the oil ring is there to retain oil, and that ring groove usually is open with holes to the underside of the piston, so oiling can get there. We also have oil holes for our piston pin as well. Real quick, what I mean by piston pin offset is where the rod actually sits as far as the center line of the piston. It's offset one way, like I said, so at top dead center, you don't get piston slap, and it makes it work, it's a little bit stronger. Okay, so there's a lot of similarities between these 2 engines and also a lot of differences. Another thing is I have a disassembled piston here. When you're measuring pistons, and there's going to be a whole video on measuring, but something interesting about pistons is it's narrower where the ring is. You cannot measure a piston up here by the ring lens. You have to measure it down on the skirt. There's that word again. So just like this hangs down over the top of the connecting rod like a skirt, just like that block, this is the skirt area right here, and this is where you actually measure. I like to measure in 2 places. You want to be in the center of the piston and right in the middle, right about there. This is a very good place to measure, and I always like to check down here too to see if the piston rocking in the cylinder has worn out the bottom side more than the top side, which is pretty common with high performance stuff. So that is rotating assemblies, kind of in a nutshell, a lot of terminology and stuff like that. You can use that to answer questions for the assignment, and we'll see you again soon.